Welcome to The Explainer. You know, we usually think of history as this one solid, straight line going back into the past. But what if it isn't? Today, we're jumping into a real puzzle, where the very same object can tell two wildly different stories, all depending on which clock you use to measure time. And this right here is the heart of the whole thing. This is an ancient piece of Jomon pottery from Japan. Now, standard dating says it's about 16,000 years old, making it some of the oldest pottery in the world. But get this, the source we're digging into today puts forward a model where this exact same pot is only 4,000 years old. I mean, how is a 12,000-year gap like that even possible? Well, to even begin to understand that massive gap, you have to realize that a date from ancient history isn't just a number they pull out of thin air. It's actually the final answer to a math problem. And that math problem is built entirely on top of a model, a whole set of assumptions about what our planet was like way back then. And really, it comes down to these two competing models. On one hand, you've got the one we all learned in school, that the past was pretty much like the present, just stretched out over millions of years of slow, gradual change. But the second model, the one from our source, it really challenges that idea. It hinges on one single game-changing event, a catastrophic global flood about 4,500 years ago that just completely rewrote the rules for Earth's atmosphere and its climate. Okay, so this is the absolute key to everything we're talking about today. The physical stuff, the pot, the bones, the layers of ice, nobody's arguing about whether it's real. Everyone agrees it exists. The entire debate, the whole 12,000-year disagreement, it all boils down to which set of starting assumptions you plug in to figure out what that evidence actually means. So let's see how this plays out in the real world. We'll start with the most famous dating method there is, carbon-14. We're about to see how just tweaking one single assumption can take a date that reads 11,500 years old and shrink it all the way down to just 4,000. All right, first, a super quick refresher. Every living thing, you, me, trees, animals, we all absorb a radioactive version of carbon from the air called carbon-14. When that thing dies, it stops taking in new C14, and the stuff it already has starts to decay, kind of like a ticking clock. So by measuring how much is left, scientists can figure out how long ago it died. But, and this is a huge but, the whole calculation only works if you know how much C14 the organism started with. And bam, this is the exact point where the two timelines split. The standard view assumes the amount of C14 in the air has been more or less the same for ages, but the source's model says not so fast. It argues that before this big flood, the Earth had a kind of water canopy in the upper atmosphere that acted like a shield, blocking a lot of the cosmic rays that create C14 in the first place. And if that's true, it means ancient life started out with way less C14 than things do today. So what? What does that actually do to the final date? Okay, let's follow the logic. Let's say an animal really died 4,000 years ago, but it lived in that low C14 world, so it only started with, say, half the C14 of a modern animal. Over those 4,000 years, that small amount decays and gets even smaller. Now, fast forward to today. A scientist finds the bone. They measure that tiny, tiny amount of C14 left. But they assume it started with today's high level. To get that low, their calculation says it must have been decaying for 11,500 years. So a genuinely younger object ends up looking much, much older. And when you apply that thinking across the board, whoa, the effect is just staggering. You look at world-famous sites like Göbekli Tepe in Turkey, conventionally dated to over 11,000 years ago. In this new model, it's recalculated to just over 4,000 years ago. Ancient Jericho, Çatalhöyük, all of them. Suddenly you see these thousands of years of what we call prehistory get compressed into a much, much shorter period, all clustered right after that proposed flood event. But this whole idea isn't just about carbon-14. The critique also takes aim at another huge pillar of deep time, those incredible ice cores drilled out of Greenland and Antarctica. You know, the ones that are supposed to be a frozen library of Earth's climate history, going back hundreds of thousands of years. I mean, just think about that number. Scientists have drilled down and pulled up ice that they believe gives us a year-by-year snapshot of snowfall going back 800,000 years. And they get that age by counting the layers, kind of like counting tree rings. And here we go again. It's a battle of assumptions. The standard model says, yup, one layer equals 1 year of pretty stable snowfall. But the sources model says, hold on. What if the climate right after a global flood was absolutely chaotic? Think of a much warmer ocean pumping moisture into the air, fueling storm after storm after storm. It argues that each major storm, not each year, could have left its own distinct layer in the ice. So, how could you get this overcounting? Well, picture one wild, chaotic year. Boom, a huge dust storm blows through, leaving a dusty layer. Then, a nearby volcano erupts, laying down a layer of ash. Then, a monster blizzard from the ocean dumps a bunch of snow heavy with sea salt. Each of those events leaves a unique chemical fingerprint. So at the end, only 1 year has gone by, but you've got 3 or more layers that look like they could be annual layers. The source also brings up something interesting about the really deep parts of the ice, where the layers are squished too thin to count visually. To date that ice, scientists often match patterns they see in it to long-term astronomical cycles. But the source argues this can be a form of circular reasoning. You're using the cycles to date the ice, and then using the ice to confirm the cycles. It asks, what if those patterns in the ice weren't caused by slow, gentle orbital changes, but by something much faster, like intense, repeating volcanic activity in that post-flood world? So, let's pull back for a second. What have we seen here? With both carbon dating and with ice cores, that final number, that final date, is incredibly sensitive to what you assume about the ancient world. Your starting point really, truly determines your end result. And let's be really clear here. The argument isn't about throwing out the data or saying the science is bad. The idea is to take the exact same measurements, the same C14 levels, the same ice chemistry, and just run them through a different historical filter, a different lens that ends up painting a radically different picture of the past. And if you were to adopt this reinterpretation, the ripple effects would be enormous. I mean, C14 dating is fundamental to so many fields. Timelines would have to be rethought for everything. Archaeology, paleontology, when agriculture started, even how we authenticate certain ancient artifacts could all be called into question. And it's not just about poking holes in existing dates. The source also points to evidence that it says actually supports its younger timeline. For example, it highlights that the oldest known living organisms on the entire planet, these deep sea corals, have a maximum observed age of about 4,300 years, a number that, you have to admit, fits pretty neatly inside a 4,500-year timeline. So at the end of the day, this whole tale of two timelines leaves us with a pretty provocative question. For those huge, vast stretches of the past, before anyone was writing things down, before there were any eyewitnesses we can check with, how much of what we think we know about deep time really just comes down to what we assume in the first place? It's something to think about.